Okay, I think that's us. So, hello everyone. My name is Areti. You've probably seen me in the video lecture so far.
Hello, I'm Sander. I've been browsing the forums and helping people on there. And
I'm Maria. I'm one of the chief assistants for the course, and I help design the course.
So we're really excited about Code Yourself. Participation is great. We already have more than 52,000 people registered on the course, which is amazing. And people from all over the world, different ages. So we've got people from 10 years old to 73 or 4, something like that, and countries like the UK, Brazil, China, Norway, Greece, the Philippines, Australia, so all over the world, South Africa, amazing stuff. So it's week 2 now, officially. We've been looking at the forum so far. Things are going great. We're very pleased with how things in the forums are going. The atmosphere is great. People are engaging. They're friendly. They're helping each other. Sandra, what is your impression from these first 2 weeks?
It's been absolutely great. The main thing I've seen is from the forums how, well, I'm supposed to help people when they have questions and answer for them. But actually, I find that I never have to do anything since there's so many users helping each other. And I think it's really amazing to see. And one of the best ways to learn programming is to help each other learn it, like to teach each other. And so that's been
excellent. And that's really the idea. You're meant to help each other, and we're just there to give you that extra support and make sure everything works well in the forum. So good stuff. So keep up the good work, yeah? Right, so what is this Hangout about and why are we having it? So first of all, it's good to just get together. We thought it's a good opportunity to answer some of your questions from the forums, point out some constructive discussions that we've seen, some really, really good examples of how people learn together. So basically, we're going to start by looking at questions from the Hangout forum. And then Sandra is going to be talking about some posts in
the week 1, just basically general things that were happening in week 1.
Excellent. And how about yourself, Maria?
I'll talk about week 2, the questions and examples that we'll point out.
And if there are any additional questions asked during this session, the Hangout session, we'll do our best to answer a couple of those as well. So, okay, let's get started. So let's see, the Hangout forum. There were several questions, very, very, very important questions. So I'm very happy with the kind of questions that I saw there. One of the main questions that came up again and again in this forum was, why learn Scratch? I think this is an excellent question to ask. And in general, the question why is something that you should be asking yourselves all the time when you're learning something. You know, what's the point of this? And how am I going to benefit from it? So why Scratch? Why have we chosen Scratch? Before I give you my answer, I am going to I'm going to mention the answers of some of your fellow students on this kind of a question. So let's see, Ashley asked, what is the goal of Scratch? And then James Greener said, Scratch helps young people learn to think creatively, reason systematically, and work collaboratively, which are essential skills for life in the 21st century. James, very well put. That's exactly it. You know, Scratch gives you the opportunity to be creative and learn how to construct programs. And we're helping you here do it in a systematic way. So good stuff. And then Nestor also added that Scratch helps you, the goal of Scratch is to introduce in a playful way basic concepts behind computer programming in general. And that several of the control structures, for instance, that you see in Scratch, these are repeated, then they can be seen in other programming languages. And that is absolutely true. And that's why we think that Scratch is a very good medium to learn, to be introduced to programming. It's all fun, it's visual, you don't need to think about syntax errors, which you'll come across when you move on after this course. And at the same time, it just gets you thinking, you learn about programming concepts, like variables. We'll see those next week. You learn about, you learn how to think computationally, so how to break down your problems, how to abstract, and these are topics we actually analyzed in week 2. And it just gives you the opportunity of trying out building programs, having a goal in mind. I want to build this, and then you can have a go and just enjoy it, first of all, and think about, what you learn from this process. All these lessons you can apply later on when you learn a new programming language. So, I suppose, long story short, Scratch helps you. It's a gentle introduction to programming, and it helps you move on in a very smooth way to a different programming language. So, which brings me very nicely to the next question. Santos asked in the Hangout forum, after Scratch, what programming languages would you recommend learning for beginners? So there are many programming languages out there. The ones that are more popular are, I'd say, Java, C++, Python, and many, many more. Very often it just depends on the type of problem you're solving, I suppose. But I think a good next step after this course, after learning how to program in Scratch, is to learn how to program in Python. And we're actually going to show how to do that. So we're going to show you the links between Scratch programs and programs in Python in week 5. So just wait for a few more weeks, and you'll see how this works. Sandra, what languages do you use? What is your favorite language?
My favorite language in general is Python, because I find it's one of the easiest languages to code in, because it's very descriptive. So, for example, if you want to know the length of something, you just use the len command, things like that. And secondly, the programming language has been written so that you are kind of forced to write nice code. So it has to look nice. So, if, for example, you make an iteration of something, you want to do 5 times the same thing, you say for 5 steps, and then below that you just make a tab, and everything that has the same tab length belongs together, belongs within that iteration. So this makes your code look really nice automatically, and that's what I really like.
Oh, and how about you, Maria?
So the ones that I focused on so far were Java and Python, and so if Python kind of makes you write your code in a very nice way, in a very descriptive way, Java does it in more, I think. So, but I agree that Python is much. It's quite easy to learn as your first programming language. Yeah, I think it's a good start.
Cool, and the good news is that there are many free online courses on Python out there, and there are many free resources as well. So once you're done with this course, we highly encourage you to move on to Python or any other language that can help you advance and get more control over your programming. And then there was another question about healthcare informatics. So what languages are used in healthcare informatics, asks Tonya Locker or Teonia Locker. I might be mispronouncing your name, sorry. So I suppose you're asking, so healthcare informatics is the research area I'm focusing on. Again, different people use different languages, even in this field, in healthcare informatics. And I'd say that it really depends on what problem you're trying to solve or what approach you're taking when tackling that problem. And sometimes it also depends on the preferences you have over a language, like Python being neat. In my case, I use Prolog a lot, which is a logic-based language. It's not as widely used as Java or Python, but it works nicely with the kind of things I'm trying to do. So in my research, I'm looking at diagnosing situations, explaining causal relationships between phenomena. So that's where logic-based programming helps, and Prolog helps. So in a sense, Prolog makes sense to me as well. So that's, I suppose, another reason why I use it. But there are many people in our school that are working on health informatics, and they use different languages. So we have people using MATLAB when looking at learning from big amounts of data. So yeah, there's not just one answer. Many options are out there. Yeah. Right, and then there was so that was Doug, who asked why the interview with the architect in week 2, and that's a very good question to ask. So in week 1 we had this interview with an audiovisual producer. Week 2 there's the interview with the architect, and there's going to be more of those. So we have both interviews with computing experts and with non-computing experts. So why care about the non-computing experts in a programming course, you could ask. The point we're trying to make is that programming and computer science has links with other disciplines as well. So just like in architecture, for instance, in the interview we had with Rob, there we talked about designing before building a house or a building, and the importance of gathering your requirements, so having a brief with a client. These are links that we can see between software engineering and architecture. And I think these are interesting, interesting things to have in mind, that there are some patterns in the way we work that you can see in other disciplines as well. In next week or the week after, we have an interview with a jewelry maker, and then there's one with a chef. So you'll see lots of links with everyday life and other aspects, other disciplines. I would highly encourage you to try to think about those links whenever you watch a video with a non-computing expert. So asking the question, why am I watching this, is the best thing to do. So try to think, okay, how does this point relate to what we do or what I have done so far when programming? And we've already got some posts in the forum about this. So we have one interesting one from James Greener for week 1. So he's identified some links between points in software engineering and in audiovisual production. So we have created a thread for identifying links between architecture and software engineering. So please just go ahead and participate and tell us what you think. Right, and then there were some more technical questions, some more specific questions. I'm not going to go into much technical detail in this Hangout because this is just us getting to know each other. There was a question about how can we save and how can we publish our project, the projects we create in Scratch. And for how to save a project, I would direct you to the Unit 1 video lectures. There's a video called Programming in Scratch, and there you can see step by step how it works when working online, when working online logged in, online anonymously, working offline. Maria has been doing a lot of work on this, so hence the smiling. And how to publish a project? That's a good question, because okay, you've built your program, now you want to share it with the world. The easiest and best way to do that would be to be logged in the Scratch website, and then just click share. And we're going to show you how to do this in Unit 5. So if you can be patient a few more weeks. Otherwise, just have a look and experiment, and it's you'll find it out to be easy. And I think that's it from the Hangout forum. That's it from me. Sander, anything that you want to point out, you want to talk about in week 1 in the forums there?
Oh, yeah, there's several things. So what we've been doing in the first week was we managed to have stress, but there were 4 things that we asked you to do from the lecture. So for example, we asked everyone to make a movie about themselves. I'm not going to mention any specific movie, but I just want to say how impressed we all were with how many movies were made, and the range of things were interactive videos and some videos where there was one video where they redid a scene from a movie.
Yeah.
And we've all been laughing, and we've not been seeing all of them because there's just too many, and that's amazing. I just wanted to point out that this was great.
Yes, and I have to say on this point that I've noticed that many of you went beyond what you learned this in week 1, which I think is great. The whole point of programming is exploring, so feel free to explore different functionalities in Scratch and just try things out to get a feel for how they work. So well done.
That actually reminds me that someone commented this. They said, "Oh, is anyone else, going beyond the lectures?" And I'm not really doing what the lectures ask us to just playing. And I think that's actually exactly what you should do if you want to learn programming.
Yeah.
It's just try things out and play. So the second thing we asked was to give some examples of the concept of selection in board games. Again, there's just too many to list. There's too many to have even seen all of them. But I just want to, for example, Sherry Power says, when playing snakes and ladders, if you land on the top of the snake's head, you slide back downward to a low number tile. I mean, there's so many more examples. I think board games are the perfect example. It's not really computer programming, but the whole concept of playing a board game is actually you're executing a program yourself. There's all these rules and iterations you go through while playing the board game. And although it's kind of like in a video game, the computer does all this for you. Like the computer behind the scenes is rolling a die to see if you get to the right square or things like that. In a board game, it's us as the players that do these things. That's why it was such a good question, and that's why there are so many answers to this, because it's exactly that program. It's one of the best examples. So these were 2 interesting things, but we also asked 2 other things. We asked you to design algorithm for alien coding, sorry. And many answers, some ranging from 7 steps, one ranging from over 100 steps on how to do it. Going forward. Yeah, it was great. And of course, the 4 goals format again. It's draw. I did a few, and all of them worked out quite well, I think.
Yes, and I really like the fact that some of you came up with an algorithm first, then other participants said, well, I get several things, I'm not sure what you mean there, and then you improved your algorithm, and then it worked.
Exactly. This is the iteration of when you program. The first time you program something, if the best programmer will just write it, will press on the green flag, and it will just not work. So you're changing things, you press the green flag, and so while you fix the error, then 1,000 others have popped up, and that's great. It's good to see it even when we write a simple toothbrushing tutorial. It's still the same. So I don't do that when I make mistakes, because it's very hard. It's this kind of thing.
And we've actually been discussing about this here with Sandra and Maria, because when programming, that's having errors in your program. That's how it is. Remember Rosa's interview, the interview with an informatics researcher in week 1. So she mentioned what I really like when programming is when I run it the first time and it works. And why does she like it? We all like it because it's rare. So when this happens, excite me. But that's not how it usually works. Yeah. Just like you said, there are errors, you correct them, then you continue building more errors, and that's how it is.
Yeah. Programming is making mistakes.
Yes,
yeah.
And fixing them. Okay. And I don't know about you guys, but I think the errors that I make every time, they really help me improve as a programmer as well. At some point, I realized I was making similar errors, so that kind of helped me realize where I should be paying more attention. So yeah.
Yeah. So that were the things we asked, and just a general feeling we got was that everyone was helping each other. And again, I can't list all of them. I just wanted to point out two things that stood out to me. Very early on, someone asked about the difference between the concepts of changing and setting. And Teresa Knott answered this by asking you to mention two biscuits, two biscuit tins. And in one tin, every time you take all the cookies out and you put 5 cookies in. You take all cookies out, you put 5 cookies in. So it's only ever 5 cookies. And so that's the concept of setting. You set a number to that variable, the cookie tin. And for changing, she explained, you just keep adding cookies to the cookie tin, and that changes the number of cookies inside and changes the number. But it doesn't set it to a new number, you just change what is already there. So that's, I quite like that.
And it's a very good analogy from everyday life to programming. And in week 3, which is starting on Monday, we're having a closer look at variables and how to define those in Scratch, how to set their value and how to change their value. And I think in our case, in the videos, we talk about drawers that have a number of items in there, but that's exactly it. Tins having a number of cookies. That's it.
And in general, there have been lots of questions about the .sp2 files, how to load them in Scratch. Luckily, user Jason Alexander Kibbe made a really useful video on YouTube, which I think we should link later actually, on exactly how to do this. And that's great to see that. I mean, there's also one video, but I've seen many users give examples by posting images or by actually rewriting the code of other people, because the project is shared, so you can actually go in and look at the code, and it's been, yeah, that's been great. That's just a general.
That's great. You know, posting a question, asking for help, and then people building on your code or remixing, as we call it in Scratch, to help you understand how to improve it. So excellent.
Yeah, so, and I guess it's really important to people to understand other people's code, because if you don't hear code, then you'll actually do quite a lot of it.
Yeah,
quite a lot
that's
of
a very good point.
So, yeah.
Cool. Anything else from you, Kwan? Or shall we move to?
I think we can. This was. Cool. I mean, there's many things.
True.
So it was nice to see that in week 2 people were just as enthusiastic as in the beginning, and also we've seen a lot of very helpful answers to the questions that were posted, and also examples to the
concepts we
asked. The questions that we asked. So, for example, if you remember the jingle exercise, Michelle was saying that she couldn't locate the upward arrow, but that in general she found it useful to kind of fiddle around with the instruction until she got things right. So I think that's a very, very important point, to try to play with things as much as you can, just to get a feel of what you're doing and have a little bit more control on the programs that you're creating.
And I think in this case, with the arrow, we were using specific coordinates as well.
Oh, yes, yes.
So I think be prepared when we're using coordinates, and especially when we're drawing our own sprites.
Yeah.
Be prepared that, yes, they might be just different, or we shrink a sprite and it's not as small or big as in your case.
Yeah.
So have better control, just like Maria said.
Yeah. So just try to play with it until you get it right, and then no problem. So at some point we were asking about examples of event-driven behaviors in sport, and like Sandra said, we got a lot of really nice examples, very, very close to the point. For example, Teresa was saying that in soccer, when the ball goes over the line into the net, the team scores goes up by 1 point. So that's an excellent example of an event-driven behavior in sport. Again, the game of cricket, if fielder catches the ball, then the batsman is out. So that's another very good example. Or in badminton, when a player score reaches 50, he or she wins, and the game is ends. So that example came Jewel.
Excellent.
Thank you very much. And yeah, we encourage you to give as many examples as you can think of, just because it really makes you get involved into the course, and really makes you really do understand that you actually got the point, and that you're doing a very good job. And there were a couple of questions related to the way sprites interact with each other, or between or the way scripts interact. So, for example, Peter was saying that he was playing with his dog, testing the code, and the dog barked and the candles went out before the blow up the candles appeared on the screen. So the question was that if it's possible to link the butterfly script and the cake script so that the candles are only blown out after the instruction is given. So this is related to a concept we learned in Unit 5. It's related to a broadcast message, as G said. So we need to add this message to the butterfly script right after the instruction to blow the candles. But we'll learn more about this in
There's more things to learn in the meantime, so
yes.
you know, feel free to experiment, but don't worry if you don't fully understand what broadcasting messages means and how it works. We'll cover this in just a few weeks.
Yes, also related to that, I think I hope I said it right. Ask if it's possible to integrate the response of one sprite to start an event for a second sprite. The example was if there are two sprites, the cat and the helicopter, if the cat produces the sound meow, then the helicopter should move. So it is possible to implement this. And again, you could use a broadcast message, and you'll learn all about it.
Cool. Well, thanks, Maria. We've been monitoring the Hangout forum, not us, but our other teaching assistant, Dave. Thanks, Dave. And there's one more question. So, Sandra, do you want to pick one of the two and just go ahead?
Hang on. I think this is a really good general question. I mean, we've kind of answered it earlier on, but this is a bit more specific. And Gul asks, what are the limitations of Scratch compared to other programming languages, such as Java or PHP?
Mm-hmm.
Maybe you're the...
I can start and then we can brainstorm. So we've talked about the benefits. It's easy to use, gentle introduction. You have predefined blocks. Now, at the same time, the thing with the blocks is that you have predefined instructions, and in some cases, you might want to be a little bit more free to specify your instructions. You might want to have better control over what a sprite should do. So with Scratch, the way it is right now, you can do lots of stuff, lots of great stuff, but up to a level, what the language provides you with. I'd say that in other languages like Java or PHP, you have a bit more control over how you define your sprites or your objects and what they can do, what behavior they can have. So I'd say this is, I mean, to me, as a learner, that's the most, the most important difference, that you eventually, when you move on to a different language, you have even more control over the behavior of your program.
Yeah. So the way I always look at this, Scratch is something that's actually quite far removed from the computer, how the computer thinks. So every block has a lot of code behind it that the computer interprets for you. So you don't have to think about, okay, how do I tell the sprite that is at the edge of the screen? It's all built into Scratch. But if you move to Python, this will not be there anymore. So you need to define more things. But even in Python, of course, some things are still done for you. So when you then move on to C, you're even closer to the computer way of thinking. And so it makes sense to start with Scratch, get the principles, move to Python, get it more, more good at understanding the actual machine language kind of. And that's how you can look at progressing through these languages as they get more complex.
Yeah.
So Sprites is great because you can actually visualize everything that that you're doing. All in other languages, it's you need a little bit more work to have. But yes, as you said, you have a lot more control over what you're doing.
Cool, great. Well, I think that's us, guys. It's been about half an hour. Before we go, let me just say that we're probably going to have another hangout in week 4. So fingers crossed. Well, next week is about remixing games. So it's a cool topic. So we'll be looking at a particular game called Pong, and we'll be learning how to modify it, to adapt it, to turning into something different, just by taking the very basic program of Pong at the beginning. So it's going to be fun. Cool. So we're looking forward to seeing you again.
Yeah.
And we'll be closer looking at the forums to see what kind of ideas you have. You post there and what kind of questions you have. And keep up the good work. Yeah, keep helping each other. We've been enjoying it very much, and we're really happy with progress you've made. Good. So see you later.
On the forum.
Bye.